Okay, in this video we're going to be looking at something that's a little more challenging, which is graphing derivatives and double derivatives. I guess in your example 1 here, it does talk about doing sign diagrams. So we'll do a sign diagram first, and then we'll look at a GeoGebra app to help us understand these a little more. So I guess we've got some notes here to follow. So we've got an original graph on this left-hand side. Here it is, where it's a cubic. And we have to draw a sign diagram. So I guess I'm going to use this bit of information here to draw a sign diagram of the derivative. See, this is the problem. We haven't got the function, so we can't do this algebraically. So this is really good to start with. We know that the notches we have down the bottom, okay, are where they are 0, okay? And it says it here, so note that zeros or x-intercepts on the graph of the derivative, or the zeros on the derivative, occur at x values or stationary points, okay? So hopefully that makes sense. There's one here, isn't there? So there's where the derivative is 0, a horizontal tangent. There's another one here. And they are the points that they are. One here, and that's at x equals -2. And one here when x is 2. So basically where your stationary points are, they are the zeros, or the points you mark on your number line, okay? I guess now we need to look at the derivative signs before and after -2. And you can see on the graph here, if I just do a couple of tangents, they are all positive tangents, aren't they? Another way you can think about it is whether the graph is increasing or decreasing. And I hope you guys all understand that the graph is increasing as we go from left to right. So we can say positive there. On this side, we can look at those tangents. They certainly look like they're negative. We can also just simply say that the graph is decreasing. That's the way I prefer to do it. And to finish here, tangents are positive or the graph is increasing. Okay, so that point there helps us get started. Where's the stationary points? Mark them on the sign diagram. And then normally I just look at where it's increasing and decreasing, and that will help me get those last signs on either side. So when we look at the double derivative, probably just going to grab this second bit of information. Zeros or x-intercepts on the graph of that are where the inflection points occur. Okay, so the zeros, which I'm looking for to mark on this guy, the zeros are inflection points. And I hope you can see here the graph is concave down to this point. There it is. It's concave down to that point, and that's where x equals 0. And then it becomes concave upwards after. So I'm just going to mark in that. And then we can actually put their signs in. So we know that concave downwards is going to be negative, and then concave upwards is positive. So that's not too bad to do. So just look at those key points to help you understand. Marking in those points there, like x equals 0, -2 and 2 is the key. And then for double derivatives, use the concavity to get the sign. For the derivative, I just used to just do increasing, decreasing. What's more difficult is to graph it. Okay, so what we might do is we're just going to go to a GeoGebra app. Okay, and I've got the graph here. And what this graph is going to do, it's actually going to graph the derivative, or do sort of like a trace of it. So at the moment, it doesn't look like there's much going on. It says drag me, so we're going to do that now. So I'm just going to move that point along. So can you see all these tangents? They're quite large values. What you're going to see in a second, there it is. What it's actually graphing is the derivative. Okay, so at this point here, it's telling me, if I read off the graph, that's a slope of 5, 5 over 1. If I move a bit higher, the derivative is 4. So you can see that the slopes are becoming less. You can see it just from the tangent line, but also from the graph. So remember, what we're graphing here in pink is dy by dx. Okay, we're doing it on the same axes, so it might seem confusing to start with, but it just realize it is dy by dx. Now we keep going down. Can you see the slope now is 3? And that tangent line is becoming less steep, isn't it? Less steep. And just like we were talking about before, I can't get it exact, but you know what I mean? At our stationary point, we're basically at our 0, right? Now all the tangents are negative, okay? And one of the points I missed earlier, but I'll say now, when we get to the inflection, there it is. When we get to the inflection, can you see we're actually at the most negative tangent? There it is, about there, most negative. And then after that negative tangent, they start to peter out and become less, okay? And notice what that means on the graph. So now I'll just go back again. We had our most negative tangent, okay? So that was -4, a slope of -4. And then they start to become less negative. The graph is still decreasing, so the slopes are still negative, but they keep become less negative, less negative, less negative until we get to our stationary point again. There we go. I'm trying to get close to it. There we go. So we got another 0 on the derivative, okay? And then note they're all positive again, and they're going to start increasing those tangents. Look how steep they get very quick, okay? And we get that shape there. So, you can think about algebraically, this is a cubic. If you diff it, it becomes a quadratic, right? So that looks like a parabola. So that's one way to help you sketch these. But I think what I'm trying to show you in the graph is a couple of things. Your inflection point on the graph is a turning point. So we'll go back to that. So the inflection point on the original graph, there it is there, is a turning point on the derivative, okay? And something that probably makes a lot more sense, we know our horizontal tangents, there we go, there's one, is a 0. And the other horizontal tangent there is also a 0, okay? And also, you just need to realize that these are gradual changes, right? The slope of the tangent just doesn't go straight from one spot to the other. It gradually changes, right? So when we do these curves, they are curves. They naturally change. All right, so I guess I've given you the answer there. So we'll go back to our graph, okay? Hopefully you can actually remember that. So we've got our sign diagram to help us here, okay? So we know from that our zeros are -2 and 2. Do that straight away. So if I want to graph the derivative graph, I know that wherever the station points are, I mark them in. Now I know there's an inflection along here, isn't there? So normally I just draw a line and go, right, that inflection on the original becomes a turning point on my derivative, okay? And then I know that, like I said before, it's increasing, but notice those tangents are becoming less. So the slopes are becoming less gradually. And then we become on this side again. There's my graph. It's not a good one, is it? It's good enough. So you just need to realize, you're probably going, well, how do you know it's like that? Well, it could look like this, right? As long as I have, well, that one's not too good either. As long as I have my zeros here, and I have a turning point along this dashed line, that's okay. All right. I'll do one more just to realize that there's many different forms of this. There we go. That one's much wider. Okay. So we're just looking for some sort of change. Remember, the tangents are positives, right? But they're becoming less, less, less. And then we hit our stationary point is 0. Then the tangents are negative, becoming most negative at the inflection. So we've got a turning point on every one of these graphs there. And then they become less negative until we hit another stationary, which is a 0 again. And then all the tangents start becoming positive and getting more and more positive. All right. And we'll get rid of all of those because we also have to do the derivative of the derivative. Okay, so I'll just go back to just drawing one of these. So on our graph, here's our stationary points. We know that there's a turning point at the inflection, and then we're done. So how do we do a double derivative graph? Let's keep it really simple. What you do is you just do the derivative of the derivative graph. That doesn't sound simple, but what I'm saying there is just, there's our blue graph. You just do the derivative of that. Okay, so if I'm looking at that graph, I'll just use a different color. I'll use a bit of an orange here. This is our key feature. So just like we did before, turning points on our graph. So we're going to pretend the blue graph is the original graph. Turning points become zeros. All right. So what we're going to do is the same sort of thing. If you look at all the tangents before it, or even just describe the graph, it is decreasing, right? So all the values are negative before it, okay? And then after it, it is increasing, so it's positive, okay? And you can think of it algebraically, it looks like a parabola. So if you diff that, you'll get a linear equation, okay? So to graph the double derivative, you just start with the derivative graph, okay? So just like before, we started with the green graph to draw the blue one. Now we start with the blue one to graph the orange one. So it's not really teaching a new concept. You're just repeating the same process again. All right, now they can be very difficult, right? And I'd like to show you a lot of examples. I'm probably only going to have enough time to do one more, okay? So there's many different angles you can take, and to be honest, the way they ask them in tests and exams, there's many different angles as well.